Hey guys, welcome back to my YouTube channel. So in this video, we are going to test your knowledge with one of the question that is asked in IES. So that is Engineering Service Exam. So here the question is that if 2.3 with the base 4 and 1.2 with base 4 which is equal to y with base 4. So all the bases are same here. So you can directly add the and say let me know the number. So please pause the video and try to answer it. If you guys find the answer, please post in the comment section. So let me go through the answer. So which is normal addition. So let's take the numbers which is 2.3 and 1.2. But the trick is that the base is 4. So if the base is 4, then different number of symbols that will come here is there 1, 2 and 3. That's it. Okay. So let's take this is simple addition with base 4. So if we had the number is coming is 5. But the symbols that is allowed here is not here. So only up to 3 is allowed. So in this case, what we have to do is that then 5 we have to normalize with the base 4. So if it happens here 1, 1 and then 4, 0, 1. So this will be the answer for 5. This is 1 and 1. So 1 bit is here, then 1 bit is carried here. Okay, I hope it is understood for you guys. So if we add this one, this is 4. So 4 is also not allowed here. So 4, which is also divided by the 4. So then, which is 1 and the remainder is 0. And again, which is divided by 4 and the remainder is 0 and 1. So if you write in this way, this is 1 and 0. So here 0 is 1, the 1 is carry, which is here. Okay, because only one bit is allowed here. If external or at the overflow happen, then we have to represent it as in a carry. The overflow, carry, everything we will detailedly discussing. But here if you see, the thing answer is that this is 10.1. So if you guys find the answer correctly, then I'm appreciating that you are in a current track. So let's go to the another one question. This is one of the very good question that asked. Actually, the people may know about the number system and everything. But here you see, there is a two constraint that they are given. What is the minimal now equivalent number for this one, and that is in decimal. So these two things you have to make into your mind and try to answer it. So I will please pause the video and try to answer it. Let me go through the answer. They're asking me the constraint that what is the minimal. So from the thing if you see, C is the given thing. So in hexadecimal, the C is equivalent is 12, right? So the minimal means the number which is next to this will be the minimal base. So this number can be represented in anything that is above this one, like a 13, 14, 15, up to infinity. Any number of base we can use it. But the minimal base will come here only, that is 13. So if we consider this is a 13, then our answer will be the minimal thing that we'll get. So if we go through it, then C, which is nothing but a 1. Usually that is represented as a 12, right? So 12 into 13 power 0, then 1 into 13 power 1 plus, then 1 into 13 square plus. So if we calculate it, then answer will be 169 plus 13 plus 12. So if we had it, we will be able to get that is a 5, 4, 1, then 6, 8, 9 and base 1. So the answer is 194. So I hope this is understood for you guys. I think this is very good question that this will ask you. Even if you try to use this one 14, 15, the answer may match. Maybe this one may come. But the minimal, what is the minimal number? So 194 is the minimal decimal equivalent that we will get for this number which is given. So this is one of the good question that they ask. So please go through. If you guys have any doubts here, please post in the comment section. So far we have discussed plenty of things about the number system. So this kind of understanding and these kind of observation will be far enough. So let's get into the important thing that the number system. So far we have studied only few questions, 1 or 2 questions may be possibility for asking in the exam. But this radix complement. So this is one of the very key feature in the number system. So let's see what is R's and R minus 1 complement. So in radix thing, there will be two kind of representation for a number we will using, that is R's complement and R minus 1's complement. R minus 1's complement. Okay, let's see what the both thing. In order to find R's complement, we have to subtract the number with R per n. So the number is the given entry in that particular branch number system. So r per n we have to do it. So r minus 1's complement can be obtained by r per n minus 1 minus that number. So the bracket thing need to be done first. Okay. So even if we add 1 to this r minus 1's complement, we will get r's complement. So that is one another kind of important thing. So r's complement can be also obtained from r minus 1's complement plus 1. So we usually follow this order. First we will find r minus 1's complement and then only we will find r's complement. Because if we directly go to r minus 1's r's complement, there will be chances for the overflow. So I will let you know how that is happening. So we already see it, right? So only if the 3-bit system is there, if the last after the 1 1 1, if that bit is flipped, then the number resulting will be 1 0 0 0. So only these numbers will be visible for us. This carry number will not be visible. So that's why we will start from r minus 1's complement. Because the thing here that Ray represented is r per n. So let's go with an example so that you guys will be understood this very much. So let's take example of decimal system. So in a decimal system, we know that r which is equal to 10. R is nothing but base radix. Okay. So the number that they gave here is the 1, 2, 3 and 4. Okay. The number of digit there is 4, that is n. So if we find r per 4, that is 10 per 4, then we will be going into the term that is 1 0 0. So this one. So this kind of a huge number will come. So this is not needed because only we have 4-bit system. So this is another 1 0. Sorry, I missed it. So we have only 4-bit system. But here you see there will be 5 numbers will be mentioned here. So that thing will not be added in our case. So in order to eliminate this representation we can't make in the 4-bit system. Because in the 4-bit system we can't represent 5 bits, right? So that's why every time we will start from r minus 1's complement. So r minus 1's complement, how to find is the 10 power 4 minus 1 minus that number 1 2 3 4. So this is in a bracket term. So first we have to do that one. So 9 9 9. So this is now 4-bit system. So we can easily represent it. So this is normal decimal system, right? So normal subtraction will be fine. So this is 5 6 7 and 8. So this is the number. This is r minus 1's complement. So in order to get r's complement, what we have to do is that we have to just add 1 to the r minus 1's complement. So if we done it, then we will be getting the 8766. So this is the r's complement. So this is the number. So we were able to find r's complement and also r minus 1's complement. So I hope this is understood for you guys. So in next class, let's start about how to find the r's complement for the binary and what is the importance of complements that are coming, how we can make use of those in a subtraction, multiplication and those things. So we can discuss these things detailedly from our next class. So stay tuned, like, share and subscribe the channel so that you guys will be notified. So please stay tuned for the next lectures.